Good morning, children. So now let us see this topic, functions. Let us see the definition for the functions. So a relation F, suppose we have a relation F from a non-empty set A to another non-empty set B. So here F is relation from A to B. Okay. So this F will be said to be a function. Okay. If each element x belonging to A corresponds to a unique element y belonging to B, and the y which corresponds in this way to a given x is denoted by f of x. This is read as f of x and is called the value of x under f, or we say that fx is image of x under f. Okay. So if f is a function from a set A to set B, then we write f colon then set A, this arrow, and B. That means f is a function from A to B. Okay. And in this case, if f is a function from A to B, then the first set A is called domain of function f. Second set is called codomain of the function f. Okay. And this set f of x, okay, which contains all images, okay, is called range of f. Okay, written as range f. So let us try to understand the definition by these examples. Okay, here you can see that I have taken a set A which contains two elements 1, 2 and B 3, 4. Okay, then I get a Cartesian product A cross B, that is 1, 3, 1, 4, 2, 3 and 2, 4. So here definition says that f is, if you have a relation f A to B, then it will be said to be a function if every element of set A, okay, is associated to a unique element y in B. Okay, and that y is only called image of this x. Okay, so let us try to understand here. So here I've got two sets A and B, and this is Cartesian product. Okay, so this is a relation. Yes, here this is A to B. Okay, here 1, 3. 1 is related to 3 by some rule. Okay, so this is a relation, but this is not a function. Okay, why this is not a function? Because definition of function says that a relation will be called function if every element of the first set, okay, every element of the first set is associated to a unique element in set B. Okay, but here we see that A is related to 3. Okay, it's uniquely related. Okay, but 2 is not associated to any one of the element in B. Okay, so this is a relation, but this is not a set. See the second one. This is a relation because you can see that 1, 4. Okay, so 1 is related to 4. But again, in this case, this is not a function because this element of A, okay, is left out. Okay, this is not associated to any of the element in B. Okay, so again, this is not a function, but this is a relation. Next, check this. 2 is related to 3. 1 is left unassociated. Okay, 1 is not related to any element. Okay, it's not related to any element of B uniquely. So this is a relation but not a function. Check this fourth one. Here again 2 is related to 4, 1 is not related to anyone. Okay, so again this is not a function. Fifth one, 1 is here set from set A. You can see that 1 is related to 3 as well as 4. So this violates the definition of function, because definition of function says that every element of set A should have unique element in B by which it is associated. So here what is happening, one is not associated to a unique element of B. In fact, it is associated to more than one element. Okay, so it's not uniquely associated to elements of B. Okay, and plus this element 2 is left without any association with elements of B. Okay, so this is again a relation but not a function. Now check this. Here you can see that 1 is related to 3, and it is no more related to any other. So it has got unique image. Next, 2 is also related, and it has got only it is related to only one element of B. So this element has also a unique image. So this is a function. This is a relation as well as function, so this becomes function. Because here you can see that 1 is related to only 3. 2 is related to only one element over here. And each element of set A are related to some element of B. So therefore this is a function. Now let us see the next one. So here you can see that each element of set A, each element of set A is related. Like 1 is related to 3, and you can see it is no more related to any other element. So 1 has got association with unique element. 2 is also related, yes, and it is related to only one element. So this becomes a function. Next, here you can see each element of set A has unique correspondence. Yes, so 1 is related to 4 and 1 is related to only 4. No other element. And 2 is related to 3 and no other element of set B. So again this is a function. Next, 1 is related to 4, 2 is also related to 4. Though they are related to the same, but they are related uniquely, because 1 is related only to 4, not to any other element. 2 is related to only 4, not to any other element. So it has got unique image. Yes, 1 has unique image. So, and for each element of set A, you can see they have got unique image. So this is a function. Next, see 10. Here you can see that 1 is left out, without any association. And the next thing is this 2 does not have unique image, because 2 has got more than one image. 2 is related to 3 as well as 4. So again this violates the rule, because function says that each and every element of set A should have association, and that association should be unique. This one is related to 4 as well as to 3. So this violates the uniqueness. Because this should have unique image, but it does not have unique image. It has got more than one image. So this violates the rule of function. And with 2 it's okay, but just because this 1 is related to more than one element, that's why this is not a function. In fact, this is a relation. This again, here you can see that this 1 is related to more than one element. So again this is not a function. Here you can see 2 is related to more than one element, so 2 does not have unique image. Though each has got some element over here to whom they are related, but here uniqueness is not there. Here you can see 1 is related to 4, 2 has got two images, not possible for function. 1 is related to 4 as well as 3, again violation of this uniqueness property. And this is empty. You can see these elements are not related to any one of the elements of B. So you can see out of these 16, out of these 16 relations, only 4 are functions. So this is what here function definition says, that a relation f from a non-empty set A to another non-empty set B is said to be a function if each element x in A corresponds to a unique element y in B, and the y which corresponds in this way to a given x is denoted by f of x, and it is called value of x under f. Okay, so here, like, this is a function. So here 3 will be called image of 1, 3 will be also called image of 2. Here 3 is image of 1, 4 is image of 2. Okay, here 3 is image of 2, 4 is image of 1. Okay, okay, now let us come to this question. Which of the following relations are functions? Give reasons. In case of a function, find its domain and range. So here we have got one relation. So here you can see these are the order pair. That means 1 is related to B, 1 is related to 5. So here you can see this 1 is related to more than one element, 3 and 5. So that means 1 does not have unique image. So this relation cannot be a function. Okay, like here we had seen, okay, like 2 has got more than one image. So this is not a function. Okay, so something like that. G 2, 1, 5, 1, 8, 1, 11, 1. So here you can see all the first components are different. Yes, so this is a function. Here you can see 2, 1, 4, 2, 6, 3, this. Here you can see all the first components are different. So this relation H is also a function. Okay, you can see this explanation and all. Okay, question. Okay, we were supposed to find the range and domain and range. Okay, so since this G was the function, so domain will be all the first components, set of first components, and range will be set of all second components. For H, domain will be set of all first components and range will be set of all second components. Done. Next question, a question f. Okay, a function f is defined by f of x equal to 2x minus 3. Find f of 0, f of 5, and f of minus 2. So here there is one function. Okay, and here function says that if you take x, okay, then that x will be related to 2x minus 3. Okay, suppose if I take, in place of x, if I take 1, then that 1 will be related to 2 into 1 minus 3. Okay, so here f of x is given as 2x minus 3. Okay, so that function, so the elements are related under this function by this rule. Okay, so if I take 0, then this 0 should be related to 2 into 0 minus 3, that means minus 3. If I take 5, then under the function f, that 5 should be related to 2 into 5 minus 3, that means to 7. Okay, that means 0 and minus 3 related. Okay, 5 and 7 is related, and minus 2 will be related to 2 into minus 2 in minus 3, that means minus 7. Okay, so here minus 3 will be called image of 0. Okay, or you can say 0 is pre-image of minus 3. In this, 5 is pre-image of 7, or you can say 7 is image of 5. Minus 2 is pre-image of minus 7, or you can say minus 7 is image of minus 2. Okay, next comes real valued function. A function f from a to b is called real valued function if b is subset of R. If second set, this b, is subset of R, then the function is said to be real valued function. You can check example over here. I have taken f from set of natural number to this interval. Okay, this is subset of real numbers, and I have defined this way, that f of n will be n upon n plus 1. So if I take any natural number from here, so that natural number will be related to one element over here, and that element will be decided by this formula. Okay, so if I take n equal to 1, then that 1 will be related to 1 upon 1 plus 1, that means 1 by 2. Okay, so if I take 1 over here, then that 1 will be related to half over here. Next, different types of functions. One-to-one function, it is also called injective function. One-to-one function means from this set, okay, no element, okay, no two elements, no two elements should have same image. Okay, no two elements from set A should have same image. Like here you can see no two elements have the same image, all have different image. Okay, so this type of function is called 1 1. Many to one, many to one means you'll find at least one pair. Okay, at least two elements which have same image. Okay, that's why many to one, because more than one elements are going to single element in B. Okay, into function. Into function means in set B, okay, some elements are left unassociated. Okay, like here you can see that A has got pre-image. Okay, 1 and 3. B does not have any pre-image. C does not have any pre-image. D has got pre-image. So in into function, what happens? In second set, some elements are left without any pre-image. Okay. Then comes onto function. Onto function means all elements of the second set B, okay, have pre-image. Okay, every element has got pre-image. Done. Next is 1 1 and onto. Okay, 1 1 and onto. It is also called bijective. So if the function is 1 1 as well as onto, then we say it's bijective. So in that case, you will see that every element in B has got pre-image, and every element and no two element in A has got same image. Okay. Now let us see this question. Here it says find the domain of the real function. Domain of the real function. So here they want to know what are the all possible values of x that you can take. Okay. So here you can see that this will be defined. Okay. Okay. This will not be defined if your denominator is 0. Okay. So clearly fx is not defined when denominator is 0. So when this denominator will be 0, so you have to factorize this. So after factorization you get this. So if you have got x equal to 3 or 4, then this denominator will become 0. So you should not have x equal to 3 or 4, okay, in place in your domain. Okay, so domain of this function will be r minus 3, 4, because if you take in place of x 3 or 4, then this will not be defined. Okay, so you have to exclude those elements from the domain. Okay, so domain will be r minus this set 1, 4. Okay, next is find the domain and range of real functions f of x equal to x square. So there is one function which is defined as this. If you take x, okay, from the first set, then it will be related to x square of the second set. Okay, so we have to find domain. So you can see that no matter what value of x you take, x square is always defined. So domain will be set of real numbers. Clearly f of x is defined for all x belonging to R. Therefore domain of function f will be set of real numbers. Now we have to find the range. So in order to find the range, what you have to do is in place of x you have to write y. Okay, so let f of x equal to y, then you get y equal to x square. Now what you do, you try to write this expression in terms of y. Okay, and x will be on left hand side separately. So you get x equal to plus minus square root of y. Now for what values of y, okay, this x will be real. Okay, so y should be greater than or equal to 0. Okay, it should not be negative. So clearly x is not real when y is less than 0. Okay, because you cannot have y negative. If you are having y negative, then x won't be a real number. So in that case, range will be all positive, okay, real numbers. So range will be this from 0 onwards to infinity. Next, this question had come in ISC 2020. Here it says find the domain and range of f of x. So here you can see that this f of x is well defined. Okay, but if your denominator becomes 0, then it won't be well defined. Okay, so f of x is not defined when 2 minus 3x is equal to 0. That means x equal to 2 by 3. So if x value is 2 by 3, then denominator will become 0. In that case, f of x will not be defined. So we have to remove that from set of real numbers. So domain will be r minus 2 by 3. Okay, now we have to find range. For range, what you have to do, you have to put in place of f of x, you have to put y. Okay, and you have to solve, and you have to write in terms of y. Okay, so after that you will get x equal to 2y upon 3y plus 1. So clearly you can see that x is not defined when denominator is 0. That means if 3y plus 1 is 0, then x is not defined. That means if y equal to minus 1 by 3, then x is not defined. Okay, so range will be r minus 1 by 3. Okay, this question I have left as a homework for you. Okay, so try this, and this is over now. This chapter gets over here.